If 2, 0. Here I see 0, 4, and this I see 4, 6. So then it's clear that the domain is between 0 is here, 4 is here, so the domain of this function is very clear to be -2 through 6. So that's our starting point. So then I get my table going. So this is f of x, and -2 to 6. Now this 0 and 4 are extremely important points, or x values I should say better, because that's where the function changes. It changes from this to this, and it changes from this to this. Okay, so remember the symbols. I recommend these symbols so you know where is the full point and where is the open point. So a bracket facing left, a parenthesis facing right, a parenthesis facing left, and a bracket facing right. And they are touching. Okay? Any questions so far? Okay, so then between -2 and 0, this is an overkill, but I like to write it up here because just in case we have any doubts or we go back and replace by mistake in the wrong branch. So -2, 4 plus 2 is 6. With 0 is 2. Here with 0, it's 2. Here with 4 is also 2. Here with 4 is also 2. And with 6 is 4. Quadratic, linear, linear. So then when I graph the function, -2, 1, 2, 3, 4, 5, 6. Right here, this is a full point. A 0, 2 is a full point, and this is quadratic. And remember, this function has a minimum. And the minimum is here. How do I know that? It's because I know how to graph x squared. And if this is x squared plus 2 will look like this at 2. But I cannot continue to the left. This is it. And I'm even going to use a different color so we understand that this is not the same function, right? On this side, at 0 is 2. It's this point. I don't want red, I want green. And 1, 2, 3, 4, it's still 2. I should put an open point. This is 2. This is the middle piece. But now I will continue to fill this in because it's still 4, 2. And at 6, so at 4, I'm sorry. So at 4 is 2 and at 6 is 4. 2, 3, 4, right here. And this is linear. Linear, linear, quadratic. So if I'm asked to find the range of this function, I will immediately say from 2 to infinity. Now, if I'm asked to write this, for example, a continuity at the point, I will write that, let's say for 0, limit as x approaches 0 from the left of x squared plus 2 must equal limit as x approaches 0 from the right of 2 must equal f of 0. And it happens that, I just want to push my computer further. And this happens that are all equal. This is 2, this is 2, this is 2. So the function is continuous at 2. Now the question is, and the same at 4. The question is this function differentiable? Let's stick with 1 point. So the question is it differentiable? So, differentiable at x equals 2. So let's find f prime of x. And now we know, very easy for us now, 2x, 0, and 1. and this is for -2 less than x less than 0. I cannot put the equal symbol here. This is for x between 0 and 4, and this is for 4 less than x less than or equal to 6. I don't know what happens here and here, right? But this is a different story. We're looking at one point for now. So the limit from 2x as x approaches 0 from the left must equal the limit of 0 as x approaches 0 from the right. If these two are not equal, then the function is not differentiable at 0. But it happens that this is 0 and it happens that this is 0. So differentiable at x equals 0. Now if you want to do test differentiability at x equals 4, same way. Limit of 0 as x approaches 4 from the left, does it equal limit of 1 as x approaches 4 from the right? No. Because this is 0 and this is 1, and 0 does not equal 1, and not differentiable at x equals 4. So a function can be continuous, but it may not be differentiable. It happens that here the tangent is unique, but here it's not. Here the slope is 0, and on this side the slope is 1. Since the two slopes are different, then the function is not differentiable. It has a corner. But you can say even here it has a corner. Yes, it looks like it, but the slope here is 0 and the slope here is 0. So at that point, the left-hand side, the limit is 0, the limit from the right-hand side is 0, so these two are the same, so it's differentiable at 0. But here, 0 and 1. So at 0 is 0 and at 1 is 1. So the slope here is 0, the slope of the tangent, and the slope of the tangent here is 1. So at this point, although the function is continuous, it's not differentiable. Any questions on this? Any questions? Okay, so any limits now? Anything that you would like to work on? Any limits? Or the difference quotient? Or differentiation rules? Very good, pay command, that was good. Anyone else? Other questions? How would you find the max min of a function? Anyone?
Max and min, don't you take the derivative
Yes.
and see where that would equal 0?
Yes. Or where it's undefined, and then you study the sign of the derivative. Yes. Good. Great.
Can you just make one note for us that you think would be like important? Only because there's a lot of chapters to go through, so I'm having trouble picking.
No, chapter 2. Just go to chapter 2 for functions and go to chapter 1 for limits. So chapter 1 for limits, you can go to the review. So that will be on page, where is the page? Here. Review for chapter 1 starts on page 181. And you have plenty of limits there. 182, page 182, 181, 182, and 183. And the review for chapter 2 starts on page, so let me write this down for you. Start from page 181 on. And the review for chapter 2 chapter 2, and there is also a chapter 2 test that starts on page 289. So for chapter 1 and for chapter 2, not for test 1. I wanted to write test 1. What else I was going to say?